So again, let's first make our old friend, the table of values. Our problem is asking us to explore the number of heartbeats in 12 minutes, so we'll fill our term number column up to 12. Now we know we're looking for the number of heartbeats after the 12th minute, and we know there are 140 beats in each minute. So if we were to make this problem into a pattern rule, it might sound something like this. You take the term number and multiply it by 140. So if we were to solve for the first term value in our table, we would multiply the term number of 1 by 140 and solve. Then we multiply 2 by 140 and so on to solve for all of the term numbers. By doing this, we can determine that there are a total of 1,680 heartbeats in 12 minutes. Again, we can also represent this problem with a line graph. For instance, we can place our term values on the x-axis and the term numbers on the y-axis. By using the graph, we can then determine the total number of heartbeats after each point in the 12-minute period. So now we can look at our algebraic equation and see how it relates to this problem. Now we know that variables can be any letter, so this time let's make A represent the total number of heartbeats, and let's make the letter B the number of minutes spent swimming. So if your heart beats 140 times per minute, we know from our table that the total number of heartbeats is 140 multiplied by the number of minutes spent swimming. So this relationship can be represented by the equation A equals 140 times B. In this problem, we're looking for the total number of heartbeats after 12 minutes. So we're going to substitute 12 for B, which we've already decided is the number of minutes. And what do we get for A, which is the total number of heartbeats? We take our original equation and substitute 12 for B and solve, which equals 1,680. And this matches both our table and our graph. Stunning. Again, we can use these variables to solve for any number that you want to substitute in. For example, what if we were searching for the total number of heartbeats after 8 minutes? So we take our equation and substitute 8 for B and solve, which equals 1,120, which again matches both our table and our graph. Algebra is amazing. Back to you, Polly.